Hello, good people of the internet. I'm back with a new episode of Terminal Tool of the Week. I'm your host, Orhun, and today we're gonna take a look at something really fun to play with. Before I go into details though, I'd like to remind you that if you like the video, subscribe and share it on your socials. It really helps me to keep making these videos and it keeps me motivated basically, so please consider that. With that out of the way, let's just dive into it. So today we're gonna take a look at something called Plastic. And Plastic is an NES emulator in Rust built with Ratatouille. In case you don't know, that's the library that I'm currently maintaining. I'd like to show you a demo of this before going into the details of how this works. So to run this, you need to first install it, right? And if you're on Arch Linux, there is a package for it. It's Plastic and Plastic TUI. And there are other ways of installing it too, so you can just check out the documentation for that. So let's try this out. I have this repository cloned here and I can run the TUI version, Plastic TUI with cargo run. It will show me this interface which I can use to select a ROM file which I downloaded from the internet. It's not a part of a repo because of copyright issues. I like Sonic, so I will just play Sonic. It will basically launch the game and you can play it as usual. Well, you can see that it's kind of pixelated and the graphics are not that great. So if you make the terminal font size smaller, this will actually get better. Let me show you another example. Super Mario Bros, a classic. Let's run it in the terminal. There you have it. Looks like this. There you go. Also, you can save state, load state, and so on. There are some options in the menu. One other mind-blowing thing that this can do is you can plug in your controller to play the game. So yeah, this is the project that we are looking into today. So what is NES, you might be asking? Well, it's one of the very popular game consoles from back in the day. It was first released in 1982. If I remember correctly, or 1985. If you had one of these as a kid, just comment down below. I'm really curious. And you can see the inside of the board, the motherboard. The funny thing about this is kind of minimalistic because they wanted to produce this as cheap as possible, also as efficient as possible. So it has a 8-bit CPU, 256 and 240 pixels of resolution, 54 colors with a limit of 25 colors on screen, and the games were just delivered in cartridges, you know. If you want to take a deeper look at this, there's this diagram. First of all, we have the CPU, which I said it's 8-bit CPU. There's the audio processing unit. It has a 2 kilobytes of RAM in total. And the cartridge actually contains the game data, the ROM, the bitmaps, and like the tiles. There's also a optional work RAM. And lastly, we have this lockout mechanism to prevent copying the contents of the cartridge. And this is the cartridge. You can see that this also contains the ROM for the game data and so on, the lockout and everything. And this is a PCB for Super Mario Bros. There are also different variants of these cartridges, which you can see from here. These are needed sometimes because you want to have more memory available for some games. So they just expanded the cartridges in some ways. You can read more about this on this Wikipedia article, Memory Management Controller, which is I think very interesting because you can see the games that needed these special cartridges. For example, MMC2 was just on the Mike Tyson's Punch-Out game. You can see the Mega Man 3 used MMC3. Also, you can see a picture here which shows the chip. There are also third-party chips as well for other games. So now we have a general understanding of NES. We can take a look at Plastic and how it handles things. As I mentioned, it implements this 8-bit CPU, all of the instructions in pure Rust, also the picture processing unit, cartridge handling, these mappers which I just mentioned, the memory management controllers, and also the audio processing unit. And this seems quite complete when you look at it. There are some mappers missing here and there, but this will actually work for majority of the NES games, I would say. We have some controls here, the key bindings, so we can take a look at the code and try to understand how it was implemented and how does it actually run in the terminal. If you go to the repository, you will see 3 crates in this workspace: Plastic Core, Plastic TUI, and Plastic UI. What we're gonna take a look at first is the Plastic Core. And this is actually where the real stuff happens. So we can take a look at CPU first because I think that's quite interesting. If you go into instruction, this is actually pure Rust and it contains all the instructions of this hardware in an enum. You can see that we have the test bits, jump instructions, loading, pushing, stuff the registers and so on. And in the mod file you can see this run instruction method which takes an instruction, calculates the result and returns a CPU run state. CPU run state is basically the state of the CPU after one clock cycle. The really good thing about this project is that it has a Rust API which you can directly use. If you look at the librs file, these modules are being exported. So if you were to write a demo example like this, you can simply run NES ROM file and get the result. In this code, you can see that I'm creating this NES struct first of all, and then I'm creating a loop which will be used to process the next CPU cycle, render the graphics, and also play the audio. Then I call this clock for frame method, which is for running the emulator for just one video frame. And later on, I can get the pixels from the emulator using the pixel buffer method. If you run this example, you will see that it's going to read the ROM data, print out the length of the pixels. And this is how you can use Plastic in your Rust project. You might be asking, how do you render things on the terminal then? Like I said, we use Ratatouille for that. If you look for the pixel buffer method in the UI module of the Plastic TUI, you can see that it simply uses a canvas module, and it allows you to draw arbitrary data on the terminal using Unicode characters. Plastic uses half block characters in the canvas, which looks like this, and it's basically drawing the data it gets from the picture processing unit on the terminal using this widget. The rest is just handling the keys and playing the audio. The graphical user interface also works in a very similar fashion. They just take the pixel buffer and then render it as an image on the interface. If you look at the code and if it looks like a bit intimidating at first, especially if you're not into programming that much, I think today's sponsor will help you a bit, which is Brilliant.org. Brilliant is a platform where you can learn by doing, with thousands of interactive lessons in math, data analysis, programming, and AI. And I especially like Brilliant because it is designed to make learning both effective and enjoyable. You can just complete short and interactive lessons in just a few minutes every day, and it helps you to develop a daily learning habit. Instead of overwhelming you with information or asking you to memorize facts, Brilliant focuses on helping you truly understand concepts step by step. By solving engaging problems and working through real-world examples, you not only learn specific topics, but also improve your critical thinking and problem-solving skills. Whether you're looking to grow personally or professionally, Brilliant makes it easy to build meaningful knowledge in a way that sticks. To try everything Brilliant has to offer for free for a full 30 days, visit the link in the description or scan the QR code on the screen right now. You'll also get 20% off an annual premium subscription. So shout out to Brilliant for sponsoring the video, and let's continue. Plastic is one of the projects that is super fun to play with, and there are like a lot of things to learn from it as well. So feel free to check it out and comment down below what you want to see next on these series. If you created a terminal tool and if you want to be in one of these episodes, just hit me up on my socials or in the comments, and I can review your tool as well. Don't forget to subscribe, like the video, and I will see you on the next one. Take care. Okay, that just crashed. Cool. Oh my god.